Hey guys, today I'm going to be doing another one of these kits from Kitroniks. They're really cool, I really like them. This one is a scrolling clock, and well, it's part of their timers and clocks subcategory of kits. Right, let's get started. Let's hop into this. So, it comes with a large amount of electronics in a bag, nicely packaged. It has all the lists of values for all of the different capacitors, the different ICs, the LEDs, etc., all of that stuff. Right, this is going to be a long, quite a large kit actually. It also has a resistor color code manual and everything. But let's get started. Okay, make sure I don't lose any of them. So we can see it has a crystal, really interesting crystal, which that just is what the timer is used with. It has a diode, loads of LEDs, LEDs to show the display. It's kind of like a 7-segment display, kind of. It has a push button switch. It has an adapter for a battery, which I don't know if I don't have. It's annoying because I don't have any of the inputs for this. Anything that I can plug into this to power it, which is a shame. But I'll do it, and maybe later I'll come back and plug the adapter in. Right. So, I mean, obviously, I'm just going to do all the LEDs first, because that is super cool, but you've got to be careful. And here it clearly shows which side is the negative and which side is the positive. So the negative is a side that kind of looks cut off on all of them, and on the LED you'll have that there as well. So also the longer lead on the LED is positive, but electrical tape over the top so that they stay in place. Okay. Solder. finally, all of the LEDs are now soldered in. They're not all perfectly lined, but wow, that took a long time. Okay, let's get going with the other components. This is the crystal, and actually, I'm not sure whether it's polarized or not. That is something I do not know. I'm just going to put it with the text facing the bottom and assume and hope that that should be fine. I also realised that I need to get better wire cutters, because damn, these things are so blunt. Right, push button switch. Two of them. So two in there. One in there and then one in the other one. Push all the way through. Okay, so what I realized doing the LEDs is because the PCB track was so small, I needed to use smaller millimeter solder. But for these push buttons, I'm using bigger diameter solder so that it goes faster. Save the smaller millimeter solder for the smaller pieces. Okay, bunch of resistors. I hope they're all the same. Yeah, they're all the same. All these resistors. I'm just going to plug them in the resistor slots. And if you don't know, resistors are non-polarized, so you do not need to put them in a specific way. However, the LEDs are polarized, so they all have to go in a specific way. Okay, so what I do like to do is bend the legs over so that I can hold it like so, and they will not fall out. I'm just going to put in this IC. So this is IC and it's called IC2. Well, that's what it says on the things. I'm going to take my Leathermans and line them up like so, and I'm just going to bend it over 90 degrees. Right like that. Possibly should have gone more. There we go. And now I can slot that IC into there, and it will lie perfectly on the, well, perfectly enough on the PCB. Oh no. Right, yeah. A problem with using the big solder is that it can just spread easily onto other pads. Okay, right. And now this IC. Okay, it comes with a holder, so to not damage the actual IC. And the holder just goes into slots like that. And electrical tape does work well here. Bring it back on screen. Just to tape that down to the board. There we go. Right, and I want to use this small solder. There we go. Right, remove the electrical tape, and we can plug in the IC, but I'm going to do that later. Right, let's look at the picture. So this thing, this diode, actually where does the diode go? Right next to, right here. There we go. Perfect, shows which direction to put it in. So diodes are like one-way valves for electricity. They only let electricity flow in one direction. The other direction the resistance is so high. It shows on the circuit board that the silver band needs to, where the silver band needs to be, and I'm just using that to position the diode, tell it which direction that it needs to be in. Right, so this is clearly the electrolytic capacitor, right, and it has a little plus because it's a circle. It has a little plus right on this side, so I'm going to put the white band on the opposite side because the white band is actually showing which side is negative. Okay, that goes in there. Bend the legs out a bit. There we go, and then solder. Right, so we have three more components. Three disc capacitors. Two of them are pretty small, and one of them is pretty large. It's a 104. It does look. There's one ceramic capacitor with 100N, which is C4, and there are two 22P ceramic capacitors. So I'm just gonna, which kind of makes me believe that that what I'm doing is correct. Okay, that there. This, and unlike electrolytic capacitors, ceramic capacitors are not polarized, so there's no markings on them for which direction they need to go in. That's done. There's only one more component to solder and one more component just to plug in. I just need to figure out which way I need to put the IC in. And it looks to me like it goes this way around. Yes. Just judging by the picture, the smaller black dot goes nearer the middle of the circuit board. Okay, and then I can just plug that in. There we go. All the pins are in. And now I just need to power it. Alright, I've just figured out, I've desoldered this out of there. I don't need that. I've got this clip, and I'm just going to solder that into this place. I figured out which way around it needs to go and everything, so this should work. I shouldn't have any problems with it. There we go. Right. I actually want to use the thicker solder. And that's not even barely on camera. There we go. Should be better. It's still kind of not great, but like there we go. There we go. Right, and now this in there. But yeah, twist the wires, make a hole. There we go. And some more solder. There we go. Right. Okay, so, well, the thing is that the connection's so dodgy. I've replaced the 9-volt battery clip, and nothing's changed. But before before I replaced it, it flickered on and off for a second. So I thought, oh, it's the actual clip that's not working. But that's not the case. Well, I don't know if that's the case or not, because I've replaced it, and this one still seems to not be working either. So maybe it's the tracks or the soldered joints or something. But it seems to sometimes just randomly flick on and off if I like tug, wiggle, or move. And that is something that you should not do, because as you can see, maybe even if I do that, just put the freshly clipped stuff. Right, okay. Oh, I don't know if you saw that. It flicked on for a second. Why? Why for a second? Why not forever? Wait, I just did it again. Or it just did it again. What does that mean? I couldn't tell you. That is also something you shouldn't do. And it's hard to clip these wires. Without cutting them too short. Sometimes these are good to use, sometimes they just cut the wire like so. Oh, there we go. That was a good cut. Right. And okay. I'm sorry about this. I think honestly the problem is just that because the connection isn't very secure. But guys, thanks for watching. I'm gonna unfortunately have to wrap it up right now because it's almost 10. Sorry, it's almost 11 and I've still got to edit this video. So guys, thanks for watching and I shall see you next time.